Hello students, YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance, California. Today I'm here with video number 4 on searching and sorting. Video number 3 we showed you all the logic of binary search. Make sure you watch that to understand the basis of binary search. In this one I'm just going to do a source code where we do binary search on a sorted string array. And I'm just going to go directly to the Xcode where code is and just show you the code and execution. Algorithm was already described in a lot of detail in the video number 3. Please watch that. So here's my Xcode. So this is my binary search function whose algorithm was described in video number 3. So we're passing an array of string and we're just going to take a bunch of names and a key, which is the name to be found in this array, and the logical length of the array to the bin search function. And let's look at the code. So we take the lowest index, which is 0. Highest index would be length minus 1. And it doesn't have to be 0. If you want to search a portion of the sorted array, you could do that too. In that case, you will pass one more parameter to this bin search function, which is the lowest index. So what we do is we may find the key in this array or we may not find it. If we found this key in this array, we return a true, otherwise we return a false. We're just going to set found to false, means we didn't find it. And as I described to you in the video number 3, our loop condition is that while highest index is greater than or equal to lowest index, when these two indexes become equal, that means we are exactly on the key, we found it. So loop will continue on until as long as highest index is greater than or equal to lowest index, and we'll be keep doing the binary split in the middle in the each loop iteration. So the way middle index is computed, in old days it was simply highest index minus lowest index divided by 2, but that was a bug. There's an interesting bug that was not found for 50 years, and finally the bug was found, and that's the non-bug form. Okay, so lowest index plus highest index minus lowest index divided by 2. If you look at it, it'll turn out to be pretty much the same, but in this one the value will be such that there will not be a buffer overflow when we compute it this way. Okay, all right. So if we land it at the middle index value being the key, then I have found it, and I set the found to be true, and I break out. But if value at the middle index is actually higher than the key, then obviously key will be in the lower half of the array. So in that case, I set the highest index to place where I'm looking for, which is middle index, and I also skip the middle index itself. So I can just set highest index equal to middle index minus 1. But on the other hand, if value at the middle index is lower than the key, that means key will be in the second half, higher half of the array. So in that case, I reset the lowest index, which is 1 higher than the even middle index, because middle index is not there. And this loop continues on until this condition becomes false. When it's found, we break out of the loop. So let's look at the main function and see how we use this binary search function. Here I have a sorted array of names. They are alphabetically sorted. I just typed in that way. All names are in lowercase because otherwise we might end up with case sensitivity issue. So I run this search loop here. I set it done to false, not done will be true. So I'll enter the loop no matter what. And then I ask the user, enter the first name to be searched in all lower cases. And I take user input. And then I call my binary search function, which takes this names array, the key that I'm searching for, and the length of the array. In this case, I fill the array to the capacity. So we just pass that. If I type a name, key name, that's not one of these, then is found will be false. This will be false, so it won't execute that. It'll do this one. But if is found is true, that means it will be name of one of these. Then it'll be true, and we'll say we found that name. This loop is designed to do as many searches as we want, because we say more searches user enter 0 to continue or 1 to stop. 0 will be false, not false will be true. The loop will execute again. 1 is true, not true is false, so we'll exit the loop. It's a pretty simple loop. We have done this before. So let me just execute that and show you this program, which is pretty much based on the binary search algorithm we did in video number 3. So let's execute that. So I'm gonna, you can see the name Tim is not there. So I'm just gonna type Tim, and it says name Tim is not found in the array. You want to search more? Yes, I want to search more. 0. This time I'll say I want to search Masha, and Masha is right here. And so name Masha is found in the array. I want to search one more. First name to search. Well, John. Is John in the array? John is not in the array, so it won't be there. And one more, Don. And Don is in the array. Okay. Take a look at one more time in the array, and you will see results are consistent. Now, I could code walk through this also through the debugger here. I don't know how much success I'm going to have with that. Do I want to even try that? Okay, let's try that. So stop that. Actually, let's just do 1 to stop, and program ended. So in order to debug, and I only want to debug inside this, I'll set breakpoint here, run again, and I'll take a name that is there. Let me see which name I want to get. I don't want something in the middle. I want a bunch of splits. So let's take Bertha. So lowest index 0, highest index will be 9, and this is my, so highest index will be 9, and 9 is higher than 0, so we'll enter the loop. So 0 plus 9 is 9 divided by 2 is 4. So my middle index should come out to be 4. See, 4. And the value in the middle index is Adam. See? And my key is Bertha. So Bertha and Adams are not the same. So which one is bigger? Key is bigger in this case. So index is 4. No, actually Adam is not. It's just showing me the first one actually. I could, okay. There is a way that I could see any particular value. Let me see, is there a way to do that? No, sorry. Okay, so let me see if I can. Okay, I'm not going to get into that. I think there was a way to do that I could actually look for certain value here, but may not be available right now. So build index is 4. There should be a way for me to get this value here in the debugger, but we can see on 4 what that is. 0, 1, 2, 3, 4. So Alan, so this is Alan and this is Bertha, and they're not the same obviously, and Alan is larger than Bertha, so that means Bertha will be in the lower half. So I'm going to reset the highest index to middle index minus 1, which will become 3 actually. So this is the one that's going to execute. You'll see that. Yeah. And my highest index became 3. So 3 is greater than 0. So I'll enter the loop again. And this time I see that's 3. 3 plus 0 divided by 2 is 1. So my middle index will be 1. And actually that's Bertha. So I'll find it this time. See? Middle index is 1. Key is Bertha. And that is, remember the array was Adam Bertha. So this time I found it actually. And there you go. Found it's true. I break out the loop. Return found. I go back to my main function. Is found is so far false, but will become true now. And is found will execute now. And name Bertha is found in the array. And it'll ask me one more. And I'll say I don't want any more. And that's the end of the story. So that's how you can code walkthrough. And that's the binary search code. There's a binary search code I've done for the array of struct. You can look up that in my ebook. Maybe I'll just put up a simpler version of that as well. But for now, that's pretty much it. And this is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California, saying goodbye from Searching video 4. And we did the binary search for a string array. Thank you.